My topic is role of artificial intelligence in radiology. So as we all know, the artificial intelligence is nowadays boom in the radiology department, or we can say in the medicine. And this topic is very important to know for the all of the new students. Those are studying the RIT subject, and those are pursuing their career in the radiology imaging technology. So role of artificial intelligence in computer tomography or as well as in radiology as for the diagnostic purposes is very important. So before moving to the direct to the topic, let's have a look on the what is radiology. X-rays were discovered by Wilhelm Conrad Röntgen on 8th November 1895. As we are celebrating this date today because it is tomorrow, but we are celebrating today. And immediately after the discovery of X-ray, the use of X-ray for clinical application was started. Not only in the clinical, also in the forensic cancer therapies. So the objective of our lecture today is to know what is the role of artificial intelligence, what is the working nature of AI, and to understand the role in the department as well as with the each and every equipment to very well know the future of radiology. And we can also can imagine the future with AI. So these are the modalities which we are working nowadays in the hospitals, or as we can say in the diagnostic centers. As you can see here, this we have the X-ray equipment, DR systems nowadays. We have IITV, DEXA, computerized tomography, DSA, C-arms, biplanar, single planar. And we have also the sonography equipment, MRI and PET-CT scanners. So all these equipments work on their different principles. As we know, the X-ray works on the attenuation, MRI works on the radio frequencies, and ultrasound works on the sonograph sound waves. So what is common in all these equipments? The common thing is all these equipments is DICOM. DICOM is digital imaging and communication in medicine. And the different workstation have their different softwares. Also, there are common softwares we are using in hospital nowadays, that is the HIS, RIS, and PECS. HIS is Hospital Information System, where we enter the details of patient from as they're walking into the hospital and walk out. All the details we put into the HIS software. And next we have a RIS, that is Radiology Information System. RIS is works under the HIS. We can say this is a sub part of Hospital Information System. Once we enter the patient's detail into the HIS and we put the examination details of patient, like which procedure he or she came for, like for the chest X-ray, chest PAView, we mark the examinations of procedure in HIS software, but it reflects to the RIS information, the RIS system, that is Radiology Information System. That means it works as a sub part of HIS. And next we have a picture archiving and communication system. This is the most important, we can say, the software or the system that is required in the hospital nowadays. So if we can say the PACS is the biggest picture, PACS is the top of them, and then HIS can work under the PACS, and then HIS can work, then RIS can work. So that means in the PACS software we can operate the HIS as well as, and we can operate the RIS as well as. So yes, this is the PACS. PACS is a common platform. When the PACS system, through the PACS system, we can access the all kind of data in the radiology department as well as in the different wings of the hospitals. Also, like we can connect the sonography equipment, echocardiography equipment, our X-ray equipment, CT, MRI, DEXA, whatever imaging equipment we have in the department, we can connect with the PACS system. And on this single platform, at a single table or workstation, we can assess all kind of images at one place. And this is also easiest for the physician or physician consultant, we can say, or for the radiologist to report at a one station for each and every kind of procedures, or every kind of, we can say, the different kind of different imagings. Like if patient came for the multiple imaging purpose in the department, like for the X-ray, CT, and MRI, and radiologists need to report. If we do not have PAC system, then what we have to do? The radiologist first have to go to the X-ray system, then he has to move to the CT, or then he has to move to the MRI. So he has to move around for the comparison purpose or for the reporting purpose. But if we have the PAC system, the radiologist can sit at one place and can do the reporting from the one workstation only. So this is the biggest advantage we have if we have the PACS system. And PEX is also a user-friendly system, we can say. So PEX giving you the all kind of features and the functions which we have in the equipment. We can say a lot more features which we don't have in the MRI system or CT system. So PEX also give us that kind of features also. So now what we think, so because our topic is to know about the artificial intelligence. So what we think, can the PEX will be the future of AI, or can the PEX can be will be seen in the some years ago PEX with AI softwares? So let's find out the perfect answer how the AI will work and how the advantages of AI will be reflect in after some years in the radiology department. So before moving forward, let's have a look which kind of artificial intelligence devices we are using nowadays. Because nowadays we know we all are using our smartphones, we all are using our smart televisions, even the touchscreen computer systems, and many kind of other smart watches, Apple watches that we are all everyone is using nowadays. If we look around, so the some major equipment that of the reflects as a artificial intelligence in our daily life, those equipments are that we are using nowadays. That is Google Assistant in all Android phone we are using nowadays. And next we have a Google Home and Mini and the Alexa and the Siri. These are the best example of artificial intelligence because these are basically work on the machine learning, deep learning and machine learning purpose. What is the deep learning and machine learning? We'll see in next slides, but these are the best example that we are using nowadays, and we are playing with these kind of equipments, but we do not know how they works. So they all are works on the artificial intelligence. So now back to the radiology department because our career our work, what we are working in radiology, so we must know is required. Let's have a look and start. So the role of artificial intelligence in healthcare is start when we enter into the hospital. Once we enter into the hospital doors automatic open and close. That is the example, also the example of AI. So here we have some infrared motion detectors. Those are work as a motion detection and is the presence of the any person or anything, and doors get automatically open and get auto close. So this is also some basic example of AI once we enter into the hospital. So here is the future reflection, I can say, with these kind of some these images can be the seen after 5 or 10 years in the hospitals where the robots will help in rehab centers, in operation theater surgeries, in patient cares, or in also the reporting and in also the surgeries also. Robotic surgeries are done nowadays in India also. Some Apollo and biggest hospital like Vedanta are using the robotic surgery equipments, but they are semi-robotic equipments. Semi-robotic, we can say the it is not completely working by their own and all. They are working with the help of the surgeons. Surgeons are giving the command to the equipments and they work and act accordingly. So this is also a set of example of AI. So now let's start with is the artificial intelligence. The artificial intelligence is not something we can easily learn or we can easily know or easily access to the equipment. It is to we have to learn about it. We have to know that we have to register that point that we can easily know that how it's working, how its pattern works, this pattern works, and how we can improve the equipments, our equipments, because it's learned on daily basis. So the here's the example that when they input the data, that is the data sensor images, then it gets the artificial intelligence and it gives us the action moment text. So what is that? So the artificial intelligence is the ability for a machine to perform a task that would normally require a person to do and like human. It is the ability to take information, make decision based on it, and cause an action to be taken, such as moving an arm, creating an image or text, or providing a suggestion. So there are some types of artificial intelligence categories which the equipments are dividing nowadays. That is the number one is artificial super intelligence. The an intellect that much smarter than the best human brain works. is a practically every field, including a scientific creativity, general wisdom, and social skills, is known as or comes under the artificial superintelligence. That means those are equipments, Alexa and Siri, and we can say the Google Home and Mini. Those comes under the artificial intelligence. And also we have the artificial general intelligence, a machine with the ability to apply intelligence to solve any problem rather than in just one specific problem. That is the general intelligence. That means as the human can do. So that these kind of devices comes under the artificial intelligence. And next we have a artificial narrow intelligence. Narrow intelligence means that they're the machine intelligence that equals or exceed to the human intelligence or efficiency at a specific risk. That means where the equipment is trying to achieve the human intelligence, like how human works. Human works on basically some emotions. The people are all around to know their nature, to know their feelings, and these kind of things, to know their actions also. Like the human brain works or react according to the our surrounding people's actions also. So the artificial narrow intelligence is comes under the machine intelligence, where it is equal or exceed to the human intelligence or to change the efficiency at the specific task. Like as we have a driverless cars, as we have our pilotless our drones. So these are the examples that comes under the artificial narrow intelligence, where we have to give the specific command to these devices and they perform the task, a specific task. So what is the recent changes has given the advantages to the artificial intelligence? Because artificial intelligence is something where we required infinite number of data, and the data, how much data is there? If there is data in billion, whatever in the forms of, it is always need more. The artificial intelligence is always hungry to get more and more data so that it can improve their results. So the cloud technology is known as we know, we are doing using Google Drives, OneDrive, server spaces, where we do not have need to require an actual hard disk or pen drive. We can we can store our data on the servers. So the cloud technology gives the artificial intelligence booms, because in a less second, the heavy amount of data can be accessed by the AI. And yes, the great processing system powers or graphic processing, so those are also helps to AI to work smoothly. And definitely the big data is a not sufficient word here, but the data requirement is always there in AI. More and more data is required. So the AI technology is starts in 1950s, and I can assure you that in 1950s in India we do not have even computers. So from where the artificial intelligence is started, and early 1950 to 1980s, just it was just an excitement state that everybody, nobody basically was know about the computers properly, but some peoples, some uh, great brain peoples, we can say, those are looking forward to the artificial intelligence phenomena that comes with the machine learning. So 1980s is also known as the machine era, where the each and every factories, each and every companies are trying to adopt more and more equipments, more and more auto working machines, so that the labors and the cost cutting can be reduced. So the era was 1980 to 2010 was known as the machine era, that is the machine learning comes forward in that particular duration. Nowadays we have a deep learning. So deep learning is given basically a breakthrough the AI that gives the boom. So what is the machine learning and what is deep learning? Let's have a look. So it's a field of study that combines statistics, computer science, and engineering to develop system capable of performing a specific task or to above a human ability. And AI refers to the simulation of human intelligence in machines that are programmed to think like human and mimic their actions. The term may also be applied to any machine that exhibit traits associated with the human mind, such as learning and self problem solving. So the machine learning is comes under artificial intelligence also. So machine learning is a type of AI that is not explicitly programmed to perform a specific task, but rather can learn iteratively to make predictions and decisions. And more data and machine learning model is exposed to its better perform over the time. And the deep learning, we can say it works as a sub part of the machine learning that use the artificial neural networks. Yes, this is use the artificial neural networks as we use as the human brain use their neural networks. It also uses the same. And after how the human brain process the information to learn from a huge amount of data. A well-designed and well-trained deep learning model is able to perform classification tasks and make predictions with accuracy. Sometimes it exceeds the human expert level performance also. So, what is machine learning and deep learning together? Machine learning and deep learning together is to think without being programmed, and it learn from the experiences by input of training data. That means if we have some kind of data, like we can mark the some buildings over there as a skyscrapers or as a multi-story buildings, and we are just entering in, giving the data, feeding data into the system, and on the daily basis we are capturing the images of some multi-story buildings, and we are also feeding into the system. So the system will automatically mark them as a skyscraper, as a multi-story buildings, or as a two-story buildings on these particular images. So that is the machine learning. Once it is going to improve or marking by its your this their on and on by their self, that will be comes under the deep learning part. And the machine learning makes the perspective based upon the skills learned from the training with the data which has been fed before. It also makes advanced statistical calculation with the algorithms. And the deep learning is a subfield of machine learning, is a type of machine learning based on multi-layer cakes. That is the data set. Like we have a multi-layer rainbow color cake is here. So which are these multi-layers? These multi-layers are once overall if we can see on the cake only. It is the input layer, hidden layers, and output layer. But if we goes to the hidden layers, which are these layers? These are the neural networks. These are the multi-stage informations. These are the input where we fed the information. Then we have a artificial neural networks that combines these signals and calculating the different weights from the data on the each neurons. And then we have the outer layer where we have the and basically full complete output result over there. So these all are connected together and known as artificial intelligence system. See, to know in detail about more in these neural networks and all these how the systems technically works and what kind of algorithms we use, this is a part of engineering technologies. This is on our part, but yes, definitely in future we people have to use these kind of equipments. Then definitely we must aware the system how the system works. So if I can say or look around about the current trend of the deep learning process. So deep learning it started from 2013, where the less than 50 articles or research purpose was there. But in now 2016 onward, there is every year more than 250 research articles are there about the deep learning every year, and the stats or this trending line is going chasing the sky also. So what is happening and how it starts? So it started from the medical image computing and computer assist intervention in the collaboration of American College of Radiology, where it's the more than 1600 attendees attend this program and more than 1000 project were submitted in on the AI projects. And similarly, Neural Information Processing System NIPS conference was sold out within 11 minutes 38 seconds. And more than 8,000 attendees were attend this program in 2017, and where more than 3,000 projects were submitted on the AI-based system or AI-based projects. More than 3,000. This is a huge number in 2017 and 18. So nowadays big industries also trying to also putting their steps into the artificial intelligence and to increasing their what we can say the equipments performance and equipments result into the medicine era. Now the dominant industries vendors formed a strategic partnership into the academic institution like GE, IBM, Philips, and many others are now investing the artificial intelligence systems. And the American College of Radiologists has announced its own data science institute, especially those will work on the only these AI equipments. And they are trying to reaches at particular stage where the best patient care and best physicians diagnostic results can be given with the help of AI systems. So now what is the future of radiology? Like if this image is more than enough, no any description is required. Like as we can see, the humans are trying to chasing the artificial intelligence, we can chasing the robots. So this will be the future. Do we really think so? Hello, let's find the answer. Is we are really going to chase the robots, or the robots are will help us, or will work under our command? Now how? So first we know how the system is works. Because I as told you earlier, this complete system is work on the training of data. Which kind of data we are going to feed into the system? This will be, and this data will be used as a basic background, basic knowledge of particular of the system. That will work as a template. And the next we feed the data on daily basis into the system will matches by will be the result will be shown on the basis of input data what we have fed. So if we feed the accurate data, definitely we have the perfect result. So the drawback is if we are going to feed the negative data or manipulated data, definitely we have the bad result. So the best set of example is like the Google photo image classifier. It is nowadays trending because people are using in their smartphones Google photo cameras to know what is the which is the image by the capturing only. So, like the Google photo image classifier is tagged a black person as a gorilla because it is work on the algorithms, and the algorithms are based on realities, but reality is not based on algorithms. So, as you can see here, the first image is that is the skyscraper that is marked perfectly by the Google scanner because these are the buildings and these are the heavily multi-story building, so these are known as skyscraper. This is the airplane wing that is also partially marked as perfect, that is this is an airplane, but this is not airplane, this is airplane wing. And this is car also marked perfectly. This is the bike, but this is also not correct. Okay, this is bike only because somebody is riding this bike, so it is not marked by the Google lens. So here is also the error. But the biggest error was because the some feature of this black lady was matching with gorilla. Correct. So the Google scanner marked as is gorilla. So this is the bad result we can say we have the from the AI systems. And by the knowing only this cap and dress, the Google scanner marked as a graduation. So as we can see with this set of bad results, the Google's the artificial scanner can also give us the bad result if we fed the bad data. So this is the human biological neural networks. As we know, we have the axon helix and the axon and synapse, or how the human brain works. And this is the human and artificial intelligence neural networks. This is completely looks like similarly same, but yes, both are working on their ability. Human's brain ability is different, but the machine's brain ability is far away from the human brains. It is far better also, far better in the way it is a far it can be processed within less time as the human brain process. So yes, both look same, but human brain works with the emotional intelligence. As I told you, the our brain works with the people we have all around and people we know and we love. So human brain works on the emotional intelligence, and the AI works with the data set. So the human will see the humanity first because we always take care, or we always care about our loved ones, and we always think about the persons the best. We can say the best care to our nearest person. But AI will not bother about the humanity because it is a machine basically. So it will not bother about the humans are there or something. It will give you the result, which kind of data we are going to fed, and we get the result as well. So our brain can be considered as a highly complex, nonlinear, or parallel information processing system. Information is stored and processed in a neural network simultaneously throughout the whole network rather than at a specific location. In other words, in neural networks, both dataset and its processing are global rather than local. So we will be thinking about the people around us, people we loved or love, best care to the patient, best diagnosis for our patient, saving the life, etc. And the artificial neural networks consist of a number of very simple processors that are called as neurons, which are analogous to biological neuron in the brain. The neurons are connected by weighted links passing signal from one neuron to another, and the output signal is transmitted through the neurons and outgoing connections. These outgoing connections split into a number of branches that transmit the same signal, and the outgoing branches terminates at the incoming connection of other neuron in the networks. So it only works on the mathematical formula and the algorithm applied pre-data set. So this is the set of short example of ANN, that is artificial neural networks. Now, how AI work in medicine? Because our main agenda is to know how the AI will going to help us in the medicine or in the our radiology department, and how it's going to work with our equipments. Our equipments, like how it will work with the CR system, DR system, CT or MRI, and nuclear medicine, and which are many more imaging equipments out there. So to so AI has excelled to recognize the patterns in a large volume of data, extracting relationship between complex feature in the image data, identifying the characteristic in the infinite number of image data, and also identify the pre-fed landmark of anatomy, pathology, and other details, and also can differentiate between the normal and abnormal anatomical structures. AI also process the images diagnosis for the diagnosis purpose rapidly as compared to the clinicians or radiologists can do. And AI also has optimized the workload and the patient flow in the hospital. So as I am going to telling you from the very first slide, which kind of data we are going to feed into the system, we have get the result accordingly. So how to feed the data in the AI system? So suppose we have these normal anatomical structure of patient's abdomen. Patient's abdomen. So if we mark each and every organ with the different color and with the perfect boundaries, as here marks the aorta in different color, liver we can say in the different color, right kidney is also different color, left kidney has a change in the different color, spleen, pancreas, each and every organ and vessels having their own color coding in the system. That's color coding is marked by the we people. That means by the humans also, because it will not going to mark by their own and on. We have to feed the data accordingly. So if we mark the same color coding with the two organs, like if we mark the liver and spleen with the same color, definitely we have the result accordingly the same, because we fed the bad data into the system. So we have to mark properly each and everything, and after that, once we're going to process the data, that we have the perfect result. So similarly, we can mark the abnormal structure and normal structure in the AI. The abnormal structures, like is the marking here, this is known as the heat mapping, where the different color codings are marked. We can see here the normal lungs has been marked in a blue color, and some pathology area is marked in different color, and highly affected area marked in the red, and less affected in yellow, and also the some suspected area marked into the green and blue coding. So these color coding is known as the heat mapping. So if we fed the data properly in each and every pre-data set, what we had fed into the system, and then we can process the data. So suppose we mark the chest PA only with these different kind of color coding data set, and once we enter the new X-ray into the system, fed into the system, we'll get the abnormal and normal result accordingly. Then the second example where we mark the different pathology in a different color, different pathology with the different pattern. So yes, the advancement with the AI is the AI can help radiologists and pathologists for the better diagnosis, and it can give us the auto image analysis AI can also shows the intelligence during the procedure to auto-correct the planning and position and scanning. And deep learning can analyze the data set of image, predict the future diagnosis, and also can help us in the scientific research. And the AI can also integrate image information so that radiologists, physicians can make the decision with the more confidence and plan a line of treatment. And definitely, what with the all these things will also give us the best care of patient. Because ultimately our goal is to give the best care or best treatment to the patient. And now the AI diagnosis efficiency nowadays is that is the automated visual evaluation. A deep learning artificial intelligence approach was used to evaluate digitize the images of each pathological structure in automated process that predict the probability that the image represent a case of pancreas, pre-cancer and cancer. The sensitivity of the approach is 91%. And also we have the some other advantages, like it can help the radiologist and pathologist for the better diagnosis. It also can give us the image. Sorry, that was the previous slide. Yes, so machine learning and deep learning are two different aspects of AI, as I told you earlier. And the future of the data computer has used feature of the data a computer has used in its decision making process. Additional efforts are needed to reveal how algorithm arrives at the decision or prediction so that the process become transparent to the clinician. That means on what grounds the system has made a result, that also we have to know. We have to see the particular form of data which we have fed and how we're getting the result so that it will be transparent to clinician also that the system had given the accurate result. And making these algorithms transparent could help to researchers identify the new biological features that can be relevant to the disease diagnosis. What is that? We'll discuss in later slides. I'm just giving the example here. That means the AI can predict the future disease also. So the reporting with AI, that is a semi-automation of reporting, because automated inclusion of quantitative of data and computer aided reporting is there. Cancer and pre-cancer scoring is there. That like we have the BI-RAD score in breast cancers. Auto adoption of style and language for reporter and reader also. Auto labeling of anatomy and pathology. As I told you, that if we mark the different properly mark the different organs in different color, definitely giving you the labeling also, the which anatomy is this, which organ is this, and the pathology also. And the auto quality control of reporting, like guide the reporter to missing points or guide the readers towards the major points. Like if the radiologist miss any point, definitely the system will help to highlight these missing points to have a look if there's some kind of pathology over there. And also it will give a highlight to the major points definitely which the clinician have to look. And it also match the data set with the older data set, and definitely it's going to help to maintain the quality output. So as I told you, the AI mimics the cognitive functions, and it started in 1950. Then machine learning is in 1980, and then deep learning is 2010. Now you will be wondering how many research papers has been published in AI. The total number of research paper published in AI is very heavy, huge number it is, because before 2007 it was 100 to 150, but from 2017 onwards it is 1,000 paper every year. It is a huge number, and in 1,000 papers, more than 50% are in medical, or is it from the medical sciences, like magnetic resonance imaging and computer tomography collectively account of more than 50% papers of current articles. And neuroradiology comes under the one third, that is the followed by the musculoskeletal, cardiovascular, urogenital, lungs, abdomen, and each. That is a 6 to 9% of the articles. So everybody, if we look around in the world, is working on the AI, especially those people who are working in medicine. So there are some set of examples of research papers which I found, and that was the giving the past, present, and future image of our AI. So in 1963, there was the first 2013. That was the first failure of 50 years of the AI. And after the 2012, the computation of Alex Gate gave a dramatically decrease in the image classification error. And after the 2016, it basically get stopped properly completely. they stop the training of radiologists. But in last 2 to 3 years, we can say from now onwards, it is 5 to 6 years. The DL algorithm has changes the completely. So there was some article in August 1963 that says the coding of Ranjan images, because that time the X-ray images were not as called. These images were called as Ranjan image. The coding of Ranjan images for computer analysis and applied to the lung cancer. So in 1963, they uses the system as to predict or to filter the lung cancers. Next, the article says the why the AI is about to make some of the highest paid doctor obsolete. That means, according to them, the radiologist and pathologist job are on risk, and that could be replaced by the AI also in 2017. So these were the some articles, one or two articles, which saying the what was the earlier view of the AI system, that it started with the best, that we can predict the cancer, we can diagnose the disease easily, and after later on it is going to give us the risk or being replaced by the AI. So AI Excel reporting system is also adopted by some hospitals in India, but it started from the King's College London and the University of Warwick in the UK, and the AI system is developed in the more than 4 lakh fully anonymized institutional adults test radiographs that was acquired in 2017 to 17. Within the 10 years, the data fed into the system, and the fully AI system was developed. So an assemble of two deep convolution neural networks was then trained to predict the clinical priority from radiological appearance. So the system performance in radiograph prioritization was tested in a simulation by using an independent set of more than 15,000 radiographs. And the production performance was assessed with the area under the reviver operating characteristic curve, with the sensitivity specifically positive predictive values, that negative predictive values also. Like on the completely statistical ground, the system performance was measured, and it gives the result where the sensitivity we found more than 70%, specificity we found more than 95, and the predictive positive predictive value 73%, and negative predictive value was 94%. So, and this study was published in 2019 on January 19 in Radiology. And the systems mammography with artificial intelligence is also they have chasing some papers. That is, screening mammography is technically challenged to expert interpreted, but AI can assist in the interpretation in the part by identifying and characterizing the microcalcifications. AI also working with the CT and MRI. Like in the CT nowadays, we are using the smart prep and bolus tracking. But basically, the smart prep and bolus tracking is not comes under the artificial intelligence system. But yes, somehow it started automatically after chasing some amount of CT number, and it hits the scan automatic. So it has placed into the AI system also. But it is a narrow. It comes under the narrow AI techniques. Also, we have a thoracic imaging with the AI. We have abdominal and pelvic imagings in the AI that can identify the nodules and characterizing the benign and malignant lesions in chest and in abdomen also. So in abdomen, basically, most of the important is to know about the liver findings to identify the malignant lesions, sources, and or anything else is there. So the data has been prioritized by the prioritizing by the AI system, so that it can be differentiated easily between the malignant and non-malignant lesions. Also, we have some chronoscopic feature, brain imaging features. These all we can do. So as we know, now we are facing the worldwide pandemic COVID-19, and how the COVID-19 pandemic, the AI is going to help us, or is helping us nowadays. So this is an observational study on the COVID-19 detection using by AI by the Mr. Bhargav Khatri, where the AI tools can detect the COVID-19 through the chest scans. How the computed tomography as a non-invasive image approach can detect certain characteristic manifestation in the lungs associated with COVID-19. Therefore, the CT could serve as an effective way of early scanning and diagnosis of COVID-19. So as we know, the maximum radiology equipment are inbuilt feature of AI and it works in the different feature modes. And then the deep learning and the algorithm is capable to make diagnosis, price, illness, degree of urgency, monitoring the COVID-19 cases. But what is happening in current scenario? So the AI tool will supplement the standard nucleic acid test. That is a particular microbiological test which we are using for to detect the COVID-19 virus. We can use this as a primary diagnostic tool. A swab of nucleic acid test can be taken in a car on any isolated location, which while a chest scan is performed in an enclosed space with the staff nearby. The technique present challenge includes the patient radiation dose, increasing the exposure to the staff and facilities, and needed for staff to use valuable personal protective equipment. And many other national and international organizations explanatory recommendation against the use of CT first line screening as a first line screening test. So the reporting accuracy was found on 98%. And the teams in China and the United States found that the lung of the patient with the COVID-19 symptom had a certain visual hallmarks such as ground glass opacities, hazy darkened spots in the lung diffuse enough that they don't block the underlying blood vessels or lung structures, and the areas of increased lung density is called consolidation. After that, Chinese technologies giant Alibaba Group announced an AI algorithm from its research unit, that is the Demo Academy, and they diagnose these kind of suspected cases within 20 seconds with 96% of accuracy. So now the question arises how to diagnose with the COVID-19. So the method was to use that is a deep learning model. COVID detection neural networks can be developed to extract visual feature from the volumetric chest CT exam to detect the COVID-19. And the community acquired pneumonia and the other non-pneumonic CT exams can be included. The imaging protocol or standard must be remain same for the each and every patient. That means the each volumetric scan CT slices with the varying slice thickness in few mm, and the reconstruction matrix must be 512 into 512 pixels. Once the deep learning model is trained, it should be quick enough to process a new testing exam. The average processing time for each CT exam should be less than few seconds on a workstation. Localization map of affected areas should be fully generated by the model without additional manual annotations. And the heat map to suspect the region of interest, for the example of COVID-19 and non-pneumonic, should be displayed. And these heat maps can represent abnormal regions while ignoring a normal regions. So as I explained you the earlier how to differentiate between the how to marking the abnormal and normal structure in the heat mapping pattern. So this is a set of example where the COVID-19 affected patients lungs cases is there. As we can see, the abnormalities are marked by the heat mapping process and the different locations. And the result will be on the basis of training and independent testing of the AI. More the data set AI will get, more the accuracy of the result we get. So now back to our prime question: can the PECs change the medicine's era? It will be the future of AI. So the can say proudly we can say the each and every equipment can work with the AI, but the PECs will be the more suitable options because the AI needs the maximum number of data set, and the maximum number of data set in radiology department we can get from at one location only, that is the PEC system. But it doesn't means that the AI cannot work with CT or AI cannot work with MRI. Independently, it can work with each and every equipment. But more suitable option will be there for the nowadays in radiology, that is the PECs, because at the one location or at the one station, AI can assess the maximum number of data from the each and every equipment, and that is also can assess to process the imaging modality also. So now how is AI going to help the students in training? Because our most important goal is to teach or to give a best training or education to our students. Those are the future of our radiology or radiography. So the advanced simulation softwares can help the students to learn the feature of equipment. AI can also help the student to stepwise practice on the equipment. Stepwise practice means like how to deal with patients step to step. As first the taking the history, after that the preparation of patient, then positioning, then the setting of our radiation exposure, KV and MS techniques, then after that printing the films. So stepwise steps it can help also. And AI can also guide the student to manage the risk associated with the procedure so that they can improve. So suppose if the uh, newly radiographer is giving a more radiation to pediatric or old patient, the AI can help us to reduce the radiation dose for the patient, each kind of patient. And it also can help us with the wrong step. It won't work forward if the first step is wrong, or we miss any step. It won't going to work. So it can teach better and give us better demonstration of the each and every equipment. So now let's have fill the virtual reality world as the virtual reality and artificial intelligence world. Virtual reality, I think we everybody know, as we have seen the virtual VR glasses in the malls and in the cinema halls, where we can feel the our 3D or 4D world around it. So you all must have a look these VR glasses. So how these VR glasses is going to, will add the better result in medicine, or we can say the better help in medicine. That's no. So I think this was the best example of the virtual reality, where the city volume rendering images of the patients had fed with the virtual reality and created a room where the virtual reality glasses can help and to look about the anatomy in detail. So as we have the features also in virtual reality to change the multiplanar, like we can convert into the cornel, societal, and axial. We can cut the section, we can zoom in, zoom out, and we can know the each and every detail of organs with the in virtual reality. We can feel it properly. So this can help to student learning also. They can help. This can also help us to for the best diagnosis for the radiologist. Also, this is going to very helpful to see each and every abnormality with a proper look. And this is also can help us surgeon to see the to plan the surgery, how to choose the safe surgery locations, or how to give the best patient care. So this can also help to the student training also, as I told you in early slides. No any patient is there, no any X-ray equipment is there. We are only VR system. The glasses are there, and we can feel the patient is sitting near the X-ray table. The equipment is there. We have to position the patient, we have to plate the image plate over there, and we have to set the collimation and the central ray. So this is how the AI can help us in the teaching for the students, as there was no any patient was there, no any equipment was there, only the VR glasses, and the students can feel the equipment, and students can do the practice. So at the one time, the multiple students can have the practice with these kind of the equipments if we have in our institutes or universities. So the most benefit of the AI medicines are, these are the reminding points as I told you earlier. So these are the takeaway message of the this lecture. That is the highest accuracy differential in the abnormal and normal radiographs, accuracy in probability to prediction in cancer and pre-cancer cases, improving the cancer screening and diagnosis, aiding the generic characterization of tumors, accelerating the drug discoveries, improving the cancer survivals, avoiding the pitfalls in the oncologies like in cancer therapies, assessing the quality cancer data. So AI also reduce the radiation dose effects that can be decreased by the 60%. 60% is a very huge number that we can decrease the, if we able to decrease the radiation dose. So the benefits of AI, that clinician make decision in the better clinical way, replace the human judgment and the certain function area of the healthcare, up-to-date medical information from the journal, textbooks, and clinical practice, experienced versus fresh clinician, 24 into 7 availability of experts, early diagnosis and the prediction of outcome of the diseases as well as the treatment. The feedback on treatment, reinforce on the non-pharmacological management, reduce the diagnostic and therapeutic errors, increase patient safeties, use cost saving associated with the use of AI. An AI system extract the useful information from a large patient volumes, assisting the making a real-time interface from healthcare alert and the health outcome predictions, learning and self-correcting ability to improve its accuracy based on the feedbacks like I told you, the driverless cars, smart homes, identifying the decreased tumors, and many more. So what is the future with AI? So the future with AI in the radiology department, I can say when the radiologist open up a chest CT, AI will have already reviewed the patient's emergency medical records, and images are will point out the some potential findings. Like the system will automatically giving us the specific basic result of the patient's data set and mark the abnormal results, and this will going to help the radiologist. It will classify normal and abnormal structures. Radiologists will be focused more on working up with the abnormal results on the biopsy treatments, advanced technologies, and Alexa kind of equipments can get the digital assistance also. Also, within the 5 to 10 years, the image intelligent equipment definitely will going to have. We have a free acquisition of tube performance, shielding protocols, positionings. During acquisition, we can do the automatic dose modulation, adjust for a movement or breathing. Post processing, we can have the by the equipment itself, that is the reconstruction, segmentation, 3D renderings, vessels view, anything. And within 10 to 20 years, basically, when the new data dimensions for the better health will be the help to answer the difficult questions like why do no smokers get lung cancers, and HPCs will bring to mix with the patients, so the social graphs and the how the home data and their other medical omics are there. That means some basic habits of the humans are not giving the disease, but the some patients are having the same disease without having their this kind of habits. So the what kind of DNA of these pathologies or microbes are working back on the background of each and every pathology. AI kind of equipments were giving the better result or better view on this. And also within the 10 to 20 years, the we have the latest like once we made the diagnosis and we cure also simultaneously. So that was all my job was today, and I'm done with it. So my question remains same. Like, can AI replace the radiologist or radiographers in